This is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to discuss about asymptotic notations. So in the previous lecture we have seen what is an algorithm, what are the analysis of algorithm, the characteristics and why it is much important. In this lecture we are going to discuss about big omega notation and big theta notation. So we all know asymptotic notations. Asymptotic notations are nothing but it is a mathematical way of representing the time complexity of an algorithm. So there are three kinds of asymptotic notations: big O notation, big theta notation and big omega notation. So big omega notation is what we are going to see here. So asymptotic notation, we have the function f of n and g of n. So big O notation represent it is always less than g of n. Theta notation represents it is equal to g of n, and the omega notation represents it is always greater than or equal to g of n. So let's discuss what is big omega notation. So remember, always big O notation represents the upper bound, and here the big omega notation represents the lower bound. Let's see why it is. So let's consider the definition f of n. So f of n is equal to big omega of g of n. That is, for if and only if f of n is equal to big omega of g of n, if and only if the condition holds true, only if there exists a positive constant c and n naught such that 0 is less than or equal to f of n, which is greater than or equal to c into g of n for all n greater than or equal to n naught. Okay, so let's consider an example. F of n is equal to 3n plus 2. If we have n value as 1, so for the function f of n, 3 into n, which is 1 in this case, 3 into 1 is 3, 3 plus 2 is 5, which holds true. If n is equal to 2, it is 8, which also holds true, and if n is equal to 3, it will be 11. So for all values of n which is greater than 1, this condition holds true. So we have said that asymptotic notations are used to describe the behavior of an algorithm. What kind of behavior does this notation is describing? So this big omega is, you can guess that the big omega notation is going to represent the lower bound. See here, c into g of n is 3n, and here it is 3n plus 2 is f of n. So c of g of n is 3n and f of n is 3 of n plus 2. So it is giving the lower bound, the least possible. So if f of n will never go below this c into g of n. So we are getting the lower bound. So what it means, in order to get the output of an algorithm, the minimum number of comparisons, the minimum number of programmatical steps that are to be executed is these many number of comparisons. So try to get that minimum number of at least upper. So big O of n is going to be give the upper bound at the most. Here in the worst case, big omega notation is giving the lower bound. Okay, so the least number of executions is given by big omega notation. So let's see what is big theta notation. So big theta notation is not a tight upper bound. In other words, n is equal to order of n squared. So theta provides a tight bound. So here the statement of big theta notation is f of n is equal to theta of g of n. This condition holds true only if and only if there exists positive constant c1, c2 and n naught such that 0 is less than or equal to c1 into g of n, which is again less than or equal to c2 into g of n for all n greater than or equal to n naught. So let's see the visualization of big theta of g of n. So this will show only the tight, it is not a tight upper bound. So remember, in asymptotic notation, big O notation represents the upper bound, the maximum number of executions to be done. Big omega represents the least number of executions to be done, and big theta notation, it represents that it does not represent a tight bound. So thank you.